Let me quickly, tell you what to be there in this project. So I, I told you like you can choose any of either mining, civil, or petroleum project. So we have discussed about these projects in our previous classes. What are the example of these rock mechanics applications? Right. For an example, I told you about this underground metal mine case where we have different kind of access like our the shaft, the main access, right, main level, and stope access, sub levels, process chamber. Okay, so these kind of examples like underground constructions are there. So you can choose any of them. So I told you either you just go for, if it is shaft you are considering, you can just consider 10-meter diameter shaft, okay, or some rectangular shaft. So this is up to you. Or if this main level you are considering, you can consider D-shaped tunnel if the stresses are not very high, or maybe you can go for rectangular tunnel or even circular tunnel. Or okay, so you choose your case for yourself. If you have any problem, just let me know. Now this is an example of your project title, how it will be looking like. For example, this is a design of main level access for an underground metal mine. Okay, so main level means this one. So we are designing one of this. And then I told you, how it should be arranged, how the report should look like. And I'll be sharing this thing with you, a word copy of this. So in introduction, there will be introduction like why and the underground structure that you are designing. Okay, so some 8 to 15 lines, geological interpretation, what is the geology in that area. Take an example. Okay, so and describe what are the geological features, right? In geotechnical parameters. Okay, in geotechnical parameters, part of this we have already done. So as I was saying, let's say you are designing a tunnel and you are passing through different type of rock A, B, C, D, E, right? And you are making this tunnel through these different type of rocks. Then use the rock lab software that we have already used to get the parameters. Okay, so for your case, don't take so many rock types. You have already considered one rock type for your homework, this rock lab homework. So in here, what we are going to do, we will just consider, let's say, type B, and that is the homework we have submitted. But only thing what we are going to do is we are choosing the this Q range of this different Q range for the same rock type. Okay, so Q range varies from 0.004 to all the way up to 100. Then I said that you can divide this total range into different ranges where these shortcut thickness they are changing. Okay, so you just divide it in group 1, group 2, group 3, like that, depending upon your pen by pen or height by ESR. Okay, depending upon this, you just divide this whole range of Q into different zones. Okay, and then what you are going to do is we have our, we discussed about this rock mass classification system and the relation between Q and RMR. You remember that? Okay, so let's say this one, RMR equal to 9 ln Q plus 44. So for each zone, what you are going to do is uh, let's say you are talking about the third. So the Q range is changing from 0. Let's say 0.05 to 0.01.17. Okay, so for 0.5 Q value 0.5, you need to calculate what is the corresponding value of RMR. RMR equal to what? And then if you know the RMR, you can calculate the GSI equal to RMR minus 5. Okay, so you just calculate it like that, and then you get the parameters for, let's say, type 3 rock. Okay, so if you know your type 3 rock properties, that will be used for your FEM analysis. So you make a table here. So what you can do is, uh-oh. So yeah, this is what maybe we were talking here. So in class 1, what is the cohesion? What is the, yeah. So class 1, what is the cohesion? What is the friction angle? What is the sigma t? All those parameters, you just find it out from your Rock Lab software for different value of GSI. Uh, and then you assume Poisson's ratio, because you cannot get the Poisson's ratio there. So you assume any Poisson's ratio between 0.15 to 0.35. Is this clear, like this geotechnical parameter part, Aman?
No, sir. Sir, I have some questions. So,
Yeah,
sir, where are we supposed to get these parameters for the rock lab part?
sorry?
Like the parameters for the rock lab part, because these are not available on the internet
No,
for
no,
that
no.
particular
You have
for that
already
particular rock,
submitted
sir.
your assignment, right?
Yes, sir.
You remember that Rock Lab thing?
Yes, sir.
So there you have some input of UCS, right? Or sigma CI,
Okay.
and then D value and all those values, right? Only thing you will change is GSI here. Okay. So for, let's say, class 1 type of rock, what is the GSI value you are going to take? So that value will change for this class 1 type. Okay, other things will remain the same. So you
So why
you
are we
use,
dividing this into these parts,
because
classes?
like when we are talking about Q range 0.04 to 100, this means the same type of rock. The rock is same. So if the tunnel is passing through different ranges of from here to here is the, let's say, you considered some sandstone rock.
So, but like if I have considered my case, there's
Mm-hmm.
only one kind of rock
Hmm.
in the whole majority has the
Yeah.
one kind of rock only. Like
Hmm.
it doesn't have different kinds of rocks.
Yes. So yeah, that is what I'm trying to explain. So what happens? Let's say this is what is your rock type?
So it's nice,
Nice.
peninsular nice.
Okay. Okay. So for that, I think it's called niche. Okay.
Yes, nice,
So
nice.
yeah. So what you need to do, like let's say, like that niche kind of rock is from here to here. Let's say point A to point B, and this is, let's say, 2 kilometer long. Okay, so what happens due to some tectonic activity or different type of structural discontinuity in the within this 2 kilometer range, even if this is the same niche kind of rock, like the properties will change within that 2 kilometer. Okay, because some shearing might happen here. So this is the worst kind of rock in here. So this will correspond to this Q value of 0.04. But another structural discontinuity is here, but maybe it is not that I mean, not that huge, or maybe the damage in rock is little bit less. So that can, form somewhere in the next zone of class, like maybe it will be in class 5. Okay, so within the same rock itself, the rock, if you consider your rock mass parameter, that will changes. The intact rock parameter will not change, but even you consider more sets of joints, and because of the tectonic activity, the as a whole the rock parameter changes. Is it kind of clear?
Okay, sir. Yes, sir.
Yeah, so let's say same D-shaped tunnel you are designing in Q value of 0.004. That means, like this will be super crust kind of rock. Okay, so highly disintegrated rock. So you are designing something in this kind of thing, and when you are talking about Q value of 100, then it is, almost intact rock with minor kind of some joints here and there. Okay, so when you're talking about the properties of this and properties of this, they are different, right? So this is what we are
Yes, sir.
talking here. So class 1 is a very good quality of rock with no joints, and this class 6 is with so many joints, is kind of crossed kind of rock. Okay, so we
Yes.
are so when we put GSI value low, very low for this Q value of 0.004, then uh, then it will represent that crossed kind of rock. This is clear?
Yes, sir. But sir,
Okay.
like, can you once again tell me, uh, we have divided the whole thing into different parts of the Q classes, Q
Uh-huh.
values.
Yeah.
Then what we are supposed to do?
Yeah. So where the support system actually changes. See from in this figure here. Can you see this figure?
Yes, sir.
Rock mass quality and this thing. So it says zone 1 is without support zone. If you excavate this tunnel, you don't need any support. Okay, so if you put this span by ESR thing here, you will draw a horizontal line. That is our this black line here, this one. Okay, this line. So in this line, wherever the support system is changing, see this is what it is done actually. So either you go for n number of zones, or what we do is we divide this whole zone where this shortcrete thickness is changing. See this shortcrete thickness is 6 centimeter here, so it is 9 centimeter here, it is 12 centimeter here. Okay, so if you take these 2 points, so I can say from here to, like, let's say this point is 1 and this point is 2. So I can say from point 1 to 2 provide some 6 centimeter thick of substrate. So if whatever the rock mass is coming, provide 6 centimeter thick substrate. Okay, so if it is in zone 3, I will say that provide 9 centimeter thick substrate. Okay,
So
because
the
what I could
ultimate
have done
objective
is
is to so
uh-huh,
the ultimate objective is to calculate the shotcrete length
yeah,
of this
shortcrete
part.
thickness.
Yes, sir. Thickness.
Yeah, shortcrete thickness and rock bolt length. So you cannot. What happens? Let me go down a little bit. So let's say you blasted this small segment of rock. Okay, so maybe this Q value is 0.4. Let's say this Q value for this segment of rock, like this is, let's say, 4 meter blast, and for this can be 0.46. This can be 0.52. So you will find Q value of different magnitude, or you will find different Q value for different segment of tunnel. It can be same, but it can be different also.
So, but
Okay.
how many segments do we have to take? Consider.
After, so how it works in real life case is, let's say the tunnel is excavated in this direction. We took a blast here. and we try to find it what is my Q value. Q equal to what? If you know your Q value, then what you will do, you will find in which class of rock this Q value is ranging. Let's say this Q value is 0.46. So then you come here to this chart and 0.46 is somewhere here. 0.4 is here and 0.1 is here. So 0.46 is somewhere here. 0.5 is here. So 0.46 is here, right? This point, somewhere there. So it is in class 4. So then I will go, what is the recommendation of class 4 support? Okay.
And so where do we find that?
We will do the FEM analysis. Okay, initially we will estimate that, from our rock mass classification system, what is the support system we need.
Sir,
Okay,
how do we
so
find the corresponding RMR value for the given value of Q?
Just a second. So this is class 4 rock, right? So for class 4 rock, it is saying that we need some 12 centimeter thick shotcrete and rock bolt of spacing 1.3 meter. You can find out your rock bolt length, right? So everything you have. So you have a rock bolt length and spacing, and what is the rock bolt length and the shotcrete thickness. So you found out that this for class 4 rock, this is the support system I need. Okay, what is that support system? Shotcrete equal to 12 centimeter, rock bolt spacing equal to 1.3 meter. You calculate what is the length from that formula and you find out, based on what is your diameter of your tunnel, and you find out what is the length. Let it be 3.5 meter. Okay, so this one we get it from, from our Q classification system. So then what I will do, I'm going to do, because these are some observation around the world. So I'm not going to believe this whole thing, right? Like if you how it can be like the exact value that this classification system is, it's kind of an indication. So then what I'm going to do is I'm going to design this tunnel, and I need to find out what are the parameters here, rock parameters or rock mass parameter. And I'll put the in situ stress with that boundary and see if this support system is good enough or not. So C support is good enough. So if it is good enough, then what I'm going to do is, I will choose this support system. If the support system is too low and because of my in situ stress is too high, what I'm going to do is I'm going to increase my shotcrete thickness. So maybe it will increase to 20 centimeter, let's say, for example, if the support is not, if support is not adequate. Okay, if it is not adequate, then I will increase the support system and do the FEM analysis again and try to see if my tunnel is stable with the new support system or not. And I will repeat that process and find out the final kind of support system for that kind of rock, that class of rock. Okay, so and then I come up with, I'll come up with this, table here. So for different class of rock, what is the rock mass classification system saying? What is the FEM support system is saying? And then you need to recommend, okay, what support system you are going to use for different class of rock. Is this clear?
Sir, how do we get the rock mass parameters?
Rock mass parameter, this is what I'm saying. See, so let's say your for Q value of 0.00, 0.04. So you calculate for 0.04 or 0.05 here, what is the corresponding value of RMR? Okay, so once you know your RMR value, can you calculate your RMR value? Can anybody tell me what is the relation between Q and RMR?
Sir, RMR
Anyone?
is equal to 9 ln Q plus 44.
9 log Q plus 44, right? So you use that equation here to find out what is the corresponding RMR value. Okay, so once you know your RMR value, you can calculate your GSI value using this formula RMR minus 5 equal to GSI. So once you know your GSI for your rock lab, you just change these values for different value of this Q values.
So, sir, the
Okay,
only thing changing is the GSI values for the
GSI,
different
yes,
sections.
yes, yes.
And sir, how many values or how many sections do we have to consider for the tunnel?
Yeah, this is what I was saying. Okay, let me explain you again. Anybody else has the same question? Actually, we have talked
Yes, sir.
about this in our previous class. But let me explain it again. Okay. So first thing is to know what is the span or what is the span or height in meter. Okay, and what type of excavation you are making, either it is very critical or some kind of temporary mine opening. So based on that, you choose your ESR value, you choose your span or maybe height, or maybe let's say you are designing a shaft, then what is the diameter of this shaft? Okay, what is the D of this shaft? So those kind of things you need to find it out. Okay, so once you found out that thing, this ratio between span and ESR, let it be 6. Okay, so
So
6 is, yes,
for a circular tunnel, the span will be its diameter.
yeah,
Okay, sir.
okay.
Yes, sir.
So it just draw, let it be 6. Okay, this is 6 meter. So you draw a line like this. And what I'm saying is where this support system is changing. Uh, so our range is here 0.004 to 100. So first thing is, like it says that for support this zone 1, which is this light blue colored zone, we don't need any support system here. So first point is this point and this point. So your class 1 rock will be from, let's say, assume this is 11, this is 10. So sorry, this is 20, this is 10. So let it be 11. So class 1 will be Q value 11 to 100. Is this clear?
Yes, sir.
So next class 2. Class 2 is, see, can you tell me what will be the next Q range?
It's 4 to 11.
No, not 4 to
No,
11.
no,
4
sorry, sir.
is, see here, the support system is not changing.
So 2 to 11.
Yeah, you can say 2 to 11 or maybe 1.8 to
Yes,
something.
sir.
Okay, so next range is 1.8 to 11 because after 1.8 the support system is again changing. So here we are defining it. It's up to you actually. Generally, what we do is we change the support like this. In real case, actually, we change the shortcut thickness. Shortcut thickness. So initially, we make it 50 thick shortcut. This is the minimum that we provide. Okay, and then next is 75 100 like that. Okay, so in a multiplication of 25 we change, but let's not do that. For us, let's make our life simple here. So this 6 shortcut, 9 shortcut, then 12 shortcut, 15 shortcut, and we have 25 sorry, not cm thick shortcut. So these are our different locations. So this will be our class 1, sorry, class 1, this is class 2, this is class 3, 4, 5, and 6. Is this clear?
Yes, sir.
Anybody other than this is Aman, right?
Yes, sir.
Anybody has any question here?
Actually, sir, I have one question.
Yes, please.
So basically, when we are considering the classes like class one, class two, and so on. So basically, it is coming in a range actually.
Yeah.
But then we have to calculate the RMR for by using a particular given value of Q. Like we cannot use a range there.
Yeah, we cannot. So we
So
will use the minimum one.
okay, sir. Okay.
Okay, so that it will be safe for all like the throughout that range. Because if you take the average or the maximum one, it will not be safe, right?
Yes, sir.
So if you are considering this, we have to consider this 1.8, not average of 1.8 and 11.
Yes, sir. Thank you.
Okay.
Yes, sir.
Yeah, that was a good question. Okay, anybody else? And I will request you guys to, start working on this. Otherwise, last moment you'll have problem. So please find your own example like we did it in our DIY lab, right? And start working on that. And drop a message, or you just can email me if you have any question. I think this is clear now, right? So once this part is done, you just calculate what is your in situ stress that we have discussed, right? And then you calculate, you just write something about the tunnel excavation and support. Maybe you'll add it later because we have not studied it yet. And then yeah, so, yeah, and drill and blast and those things. You just support system. What support system you are going to provide? For our case, maybe it is the rock bolt and shotcrete. So you just explain a little bit, few lines about this shotcrete, how it works and what it is, right? Like those kind of things. So now in in design methodology, what is our approach that we have already discussed? That first we will be accessing or assessing our this support system using our rock mass classification system. Then we will do on-wedge analysis, and then we will do FEM modeling. Okay, so you just explain the concept here, and then for your case, what is this thing? Initial estimation of support based on Q and RMR, and rock bolt system, rock bolt set shortcut, what that you need, based on your classification system, and then using FEM analysis, validate whether this is adequate or not. If not, what is the new support system that we are going to put? Okay, and then uh, and then find out what are the support system as for your FEM analysis that you need, and then you need to talk about this on-wedge analysis, that I will show you maybe in next class how to do that. And you put this table, this is very important, like you divide it in class and support as per the rock mass classification system, support as per the FEM classification system, and what you recommend. Okay, so either you are going for this rock mass classification system or FEM recommendation that you need to provide, and finally you can put uh, a reference, and you put these figures as an extra. Okay, so like the FEM results. Okay, and yeah, and always results also here. Is this clear? And anybody has any question? So it will carry around 40% of your marks. So please let me know if you have any question or anything. So this is very important.
So what kind of project should we choose? Like, we don't know how big is too big. So
How big is?
too big for us to solve in 7 or
No,
14 days,
you
whatever.
just take one simple example. As I'm saying, you don't need to design this whole underground metal mine thing. You just take one section of this, let's say, main axis. So that's it, and you follow the procedure, because rest of the thing, if you want to design this stope access or maybe this crusher chamber, so it is kind of repetition of everything. So maybe your rock mass parameter there in that different place will change, the in situ stress will change, maybe the shape of the excavation will change. So you are not going to do that. We, for an example case, just to understand the concept that we studied in this course, so you need to take only one example. Okay, so from here, what you need is maybe shape of the excavation. You need to know what is the depth. Okay, or maybe the rock properties, what rock you are getting, and maybe a little bit of geology. Is this clear? So don't think it as a very complex case. As just make your life simple, or maybe take this, like design of this shaft. So the shaft depth changes from 0 to, let's say, 1,000 meter. Okay, and you assume that the rock is same, but the class of rock is changing from this to this. Okay, so in that case, your in situ stress will also change. Is this clear?
Yes, sir.
I'm sorry, who has asked that question?
Yes, Saurabh Raj.
Oh, Saurabh, yes. So is this clear, Saurabh?
Yes, sir.
Yeah, this is not too critical kind of thing, because we are doing some two-dimensional analysis here. It should not take uh, huge amount of time. The only thing is you need to change the support system and see whether the whole thing is stable or not. Okay.
Yes, sir.
Yeah. You will like you'll encounter many questions when you solve this. Like for example, something is, let's say you did FEM analysis, and whether this is stable or not. How do you know, right? So when you are saying this much support system is good enough, so how do you decide that this is good enough or not? Okay, in all the cases, it will not, so like the whole thing will collapse. Okay, so I will request you to start working on this. It will be fun, and then you'll find more and more problems, or maybe more and more questions to ask. Okay, so when is your final exam?
The 7th to 14th April.
7th to 14th April. Okay. So we have very few days left, right? Okay. So yeah, please try to submit it before 31st of this month. Is this clear?
Yes, sir.
Okay. Don't write too much. Okay, don't spend time on the necessary couple of, in each section, 4 5 lines or close to, 5 to 10 lines will be good enough to explain what you have done. Okay.
So,
Yes.
so can we find any examples so that we can refer to that?
Example.
Yes.
Yeah, you can try, right? You can just go to Google, right? So and try finding something. But I explained it very clearly, right?
Yes, sir.
So if you have any problem, just let me know, and I'm going to share this whole thing, like how it will be written, and these things, like what will be the subheadings and everything. I'm going to share. Okay, maybe tonight. So you just fill it up. So that is your work. Okay.
Yes, sir.
Because I'm saying, like, you just depth also you don't need to worry about. I'm saying that depth should be between 400 to 1000 meter. Any depth you just choose. Okay. And density, any density you choose. Okay. The K value you can choose anything from 1.5 to 2. So you take your case study and try solving it. Okay. So if you start working on this, then I can help you with, if you have any question.
Yes, sir.
Okay. And let's keep this due date, as I'm saying, 31st of this month. 31st due date. You okay with this? Very good. Okay, so, and any idea about, is this, you'll have your offline exam, right? Anyone?
Yes, sir.
Yes, sir.
Okay, so let's take some 5 minutes break, and we will start a new chapter, which is called this ground reaction curve. Okay, so at 9 o'clock.